8.3 special right triangles. We have a couple of special right triangles, and the first one is the 45 45 90 degree triangle. Right? And in a 45 45 90 degree triangle, we have one leg is the same length as the other leg, and then the hypotenuse is the length of the leg times square root 2. Right? So if this leg happens to be 7, then we could figure out the length of the hypotenuse by multiplying 7 by 7 square root of 2. So here's the example. If the leg of a 45 45 90 right triangle is x units, show that the hypotenuse is x square root 2 units. So we got to kind of show this using the Pythagorean theorem, right? So let's assume that we didn't know this. So I'm going to go ahead and cross it out like so. And so how would we show it? Well, we would do x squared plus x squared is equal to y squared, right? So let's say the hypotenuse is h. Okay, so let's say h squared is equal to x squared plus x squared. Right, this is the Pythagorean theorem. And then we're going to simplify, and we'll say h squared is equal to 2x squared. And then from here, we are going to square root both sides, right? So we'll square root both sides, and we'll get h is equal to the square root of 2 times x, right? So I am doing the prime factorization here. And we know if we have two factors, we could take one out of the square root. So h simplifies to x times square root 2. Right? So we have proven, or we have shown ourselves using the Pythagorean theorem, that this ratio holds, right? So the 45 45 90 degree triangle has a leg of length x and the other leg of length x as well, both the same length. And then the hypotenuse is going to be that leg length times square root 2. So over here, example 2, we have a 45 45 90 degree right triangle, and the hypotenuse is square root 2 times the leg. Yes, we've shown that to be true. If the hypotenuse is 6 units, find the length of each leg. Okay, so for this problem, let's go ahead and draw it out like so. We're going to say that's 45 45 90. And the hypotenuse is going to be 6. Right? And we're trying to find the length of each leg. So this is going to be is 2 times the length of the leg. Okay. So the hypotenuse is 2 times. So let's say the length of the leg is L. And we have L here. And I'm going to say the hypotenuse, H, is equals square root 2 times the length of the leg. Okay. And so now we know the length of the hypotenuse. It's 6. So we can plug it in here for h. So we'll get 6 is equal to square root 2 times the leg. And then to solve for the leg, we can divide by square root 2 on both sides. And we'll get the leg is equal to 6 over square root 2. And if we want to simplify this, we know we don't want a square root in the denominator, so we can multiply by square root 2 over square root 2. And we'll get leg is equal to 6 square root 2 over 2. And then we can simplify that further, because we could divide both 6 and 2 by 2. So that simplifies down to 3 square root 2. Right, it's our answer. So anyhow, we need to draw back on our ability to simplify fractions that involve a square root in the denominator. And it's pretty much simple algebra to solve these problems involving 45 45 90 degree triangles. And I guess I can go ahead and continue on to the other type of special triangle. It's 30 60 90 degree triangle. And a 30 60 90 degree triangle follows what is the ratio? So we have x is one leg, and then we have 2x is the hypotenuse, so 2 times the leg. And then the other leg, in a 30 60 90 right triangle, the hypotenuse is twice the shorter leg. Show that the longer leg is square root 3 times the shorter leg. Okay, so the longer leg is square root 3 x times x, or x square root 3. Right? And so we got to show that to be true. So how are we going to show that to be true? Well, we're going to use the Pythagorean theorem, right? So I'm going to go ahead and cross this out, and I'm going to use L as my variable for the longer leg. Then we're going to say L squared plus x squared is equal to 2x squared. Remember, I'm putting parentheses around the 2x, and that ensures that when we take it to the power of 2, the power distributes to the 2 and the x. So we'll get L squared plus x squared is equal to 2 squared times x squared. We'll simplify that to L squared plus x squared is equal to 4x squared. And then we need to solve for the leg. So we're going to subtract a x squared. And so we'll get L squared is equal to 3x squared. And now we're going to square root both sides. So we're going to get L is equal to the square root of 3 times x. We're doing the prime factorization of what's under the square root. And you can see we have 2 x's under the square root, or 2 factors of x, so we can pull one out. So leg is equal to x square root 3. And we've shown that it's true, right? That in a 30, 60, 90 degree triangle, the shorter leg is x, the longer leg is x square root 3, and the hypotenuse is 2x. So we can use that to solve problems, and let's go ahead and use that ratio to solve this problem in example 2. We have a 30, 60, 90 degree triangle. The hypotenuse is 5 centimeters. Find the length of the other 2 sides of the triangle. So we know the hypotenuse is 2x, right? So we could set 2x, or let's go ahead and do it like this. Let's say h is equal to 5 centimeters. We know what h is. H is 2x, right? So we'll plug that in. 2x for h equals 5. And we'll say x is equal to 5 divided by 2, or that can be simplified to 2 and 1/2. Okay, so this is the shorter leg. Now what about, so this is x, right? So then we can go ahead and plug back in to the hypotenuse equation. And so the hypotenuse is equal to 2x. And we know x is 2.5. So we're going to go ahead and plug that in, and we're going to get that into 2 times 2.5. And then that's going to equal to 5. So we know the hypotenuse is 5. And now we need to get the shorter leg using the value that we got for x. So the shorter leg is x. So x is equal to 2 and 1/2. That's the shorter leg. And then we have the longer leg, and we've proven above that the longer leg is going to be x times square root 3. So we're going to say the longer leg, I'm just going to use L as my variable, is equal to x square root 3. And then if I plug in my 2.5, that's 2.5 times square root 3. And yeah, I think I'm going to go ahead and leave it like that. So it's 2.5 times square root 3. And if I drop that into a calculator, let's see if I can get my calculator to do this. 3 square root, okay, good, times 2.5, so 4.33. So it's equal to 4.33. And we have the hypotenuse, we have the shorter leg, and we have the longer leg, right? And that's how we're going to use these types of ratios for the 45, 45, 90 degree triangle and the 30, 60, 90 degree triangle to solve problems over here. And I'll go over the answers in the next video.